All right, page 2 of the 3.2 notes. Here we're going to actually start graphing these functions. And again, it's not going to be as bad as you might think. Okay, so example 3, sketch the graphs of the polynomial functions, label all the x and y intercepts. Now, a couple of things that might help us graph these a little bit easier is knowing what our first term is going to be. In other words, if I multiply this out, what would my first term be? Okay, well, x times x times x will just be 1x to the third. Okay, and then what does that tell us? Okay, well, first of all, our exponent is odd. Our leading coefficient is positive 1, so it's positive. And then that stuff tells us what? Well, what's our in behavior going to be if it is odd and positive? Okay, so again, think like a line with a positive slope. That's going to be low to high. So then knowing that it's low to high is going to help us out a bit. Okay. All right, what else do we know? Let's see. One thing that we actually need to label anyways is our x-intercepts. Where are our x-intercepts going to be? Positive 1, so we'll put a point there. Negative 4, 1, 2, 3, 4. And negative 3. Sorry, positive 3. All right, so we know that we got those three x-intercepts. Now there's two ways that I can graph these. One is I can kind of start with the y-intercept, or I can start with the in behavior. Now sometimes the y-intercept is also an x-intercept if you have the point 0, 0 on there, so the in behavior might be a little bit better to go off of. But what's the in behavior going to be? Okay, well we said it's going to be low to high, so that means, well, when I cross through this point, and first of all, is it going to cross or bounce? Well, this is x minus 1 to the first power, x plus 4 to the first power, x minus 3 to the first power. So like we said on the first page of these notes, if it has a multiplicity of 1, and not a multiplicity of 1, but any odd multiplicity, it could be 3, 5, 7, or whatever, then it's going to go through that point. And if it has an even multiplicity, it's going to bounce at that x-intercept. Okay, so let's see. I know it goes low to high. So going to the left forever, it's got to go down somewhere that way. Going to the right forever, it's got to go up somewhere that way. So I know what my in behavior is going to be. I know it's going to, kind of go this way, that way, and up that way. And then what's it going to be? What's it going to do in the middle of all this stuff? Well, I know it's going to go through at this point, so I can draw a point, at a curve going through and coming back down and going through that one, and then going back up and going through that one. So we can just use the in behavior to do that. Or we could use our y-intercept. What would our y-intercept be here? Okay, let's figure that out later. Let's just use the in behavior for this one. So again, I know it's going through at all 3 points, so I'm just going to go through this point here, come back down, got to go through that point there, and then go through that point there. Now when you draw these graphs, first of all, does it go up exactly this high and exactly this low? I don't know. We're not worrying about those details. We're just worrying about the in behavior and getting through the correct x-intercepts. Okay? Now let's see, according to my drawing, my y-intercept should be, well, some positive number. And what should that positive number be? Let's see, if I plug in x is 0 here and here and here, then I get negative 1 times negative 3 is positive 3 times 4 is 12. So then this point here, we're saying is 0, 12. And is this actually at a height of 12? Maybe not, but again, you can change the scale on your graphs, so it's 0, 12 as long as I say it's 0, 12. Okay, so my y-intercept, we'll label it over here, is 0, 12. And then what are my x-intercepts? Okay, let's see. We had one at negative 4, 0, 1, 0, and 3, 0. Okay, and then that's a good enough sketch of our graph. Again, it might not go this high. It might go higher. I don't know exactly what this curve looks like, but I know it's going to go through these 3 points. I know my in behavior is low to high, and I should have an y-intercept at 0, 12. So this is close enough. Okay, so we're not going to worry about the exact details of the graph. If you want to know exactly what this thing looks like, you can go punch this equation into Desmos and it'll show you. Okay, but it's going to look something like this. Okay, so again, we're not worried about all the details, mainly just the in behavior and the intercepts for the most part. All right, next, sketch the graph of the next polynomial function, label the x and y intercepts, so same instructions as last time. Okay, so let's see, if we're going to graph this thing, I need to know where does it cross the x-axis. Well, it's going to cross at negative 3. I shouldn't say cross because it might bounce. So anyways, it's going to hit the x-axis at -3, and +2. Okay? All right. Before we start graphing this thing, let's write down a few more details that'll help us out. If we multiplied all this stuff out, what would our first term be? Let's see, I got 2 times x twice, so 2 times x is 2x squared, times another x is 2x to the third. So we get 2x to the third would be our first term in that polynomial if we multiplied the whole thing out. So since it's odd and positive, so again it's odd because it's a exponent of 3, it's positive because our leading coefficient is +2, and odd and positive, well, just like last time, our end behavior is going to be low to high again. Okay, so that's good. So knowing that, since these are my only 2 x-intercepts, I know it's going to go down that way and up that way. Okay, and then what's it going to do in between? Okay, now one thing that might help us is getting our y-intercept, but we don't even need that. What we do need to know is what's it going to do at each of these intercepts. So since the factor of x plus 3 happens twice, in other words, this has a multiplicity of 2, it's going to bounce here, and then it's going to go through here. Okay, and this should match up with how we have it drawn. In other words, we shouldn't cross the x-axis any additional times to make this work out. So let's see, if it bounces here, it's going to come off and bounce and come back down, and then go up and through there. So yeah, good, it works. I didn't have to make any extra x-intercepts. Make sure you don't cross the x-axis any more times than you have your x-intercepts. Okay. All right, and then according to this, let's see, our y-intercept should be some negative number. Let's label we'll do the y-intercept first. Okay, so what is our y-intercept? If I stick in x is 0, we get 0 plus 3 is 3, 3 squared is 9, times 2 is 18, times -2 would be -36. So 0, -36. Okay, so then that point is 0, -36. Now it might not look like it, but again, this has the tick marks. This, is 1 unit each. This I can kind of make my own scale. So it's 0, -36 as long as we say it is. And then what are my x-intercepts? Well, I got one at -3, 0, and +2, 0. Okay, and again, does it really go down to this point? Should it go down lower and come up higher? We don't know. We're not worried about those details. Okay, as long as your intercepts are correct and your end behavior is correct, that's the main stuff we're looking for. Okay. All right, last one. Pretty much the same instructions here. Sketch the following function and label the x and y intercepts. All right, so to help us label this, to help us graph this, let's label a couple things up here. What would my first term be if I multiplied this out? So we got -2x squared times x because I have that twice. So then that would be -2x to the fourth would be our first term. Okay, so let's see. This one is even because it's x to the fourth, and then it's a negative leading coefficient. So if it's even and negative, so if even, think like a parabola, that's negative, and I didn't need to put -1. In fact, it's -2. I don't know why I put that. But just negative is what we really need. Then that's going to open down, which is going to be low to low. Okay, so our end behavior is going to be low to low. Okay, and then what are my x-intercepts? Well, when is this factor going to be 0? When x is 0. So then I got one at 0, 0. Again, anytime we have a monomial with x in it, we're going to get an x and y-intercept at 0, 0. And then when is that factor going to equal 0? When x is -2. Okay, so then there are my 2 x-intercepts. I know my end behavior is low to low. I'm sorry, it's not. It is low to low. I'm thinking ahead. So I know it's going to do that. And then since this has a multiplicity of 2 and this one has a multiplicity of 2, it should bounce at both. So then going from left to right, it's going to come up here and then bounce, come back down, go back up, and bounce and come back down. So our graph's going to look something about like that. Again, not perfect, but good enough. My intercepts are correct, my end behavior is correct, and yeah, everything fit when I connected the dots. Okay, so our y-intercept. We don't have to do any work here. It's right there at 0, 0. Our x-intercept, we have 2 of them at -2, 0 and 0, 0. Okay, So again, when we're graphing these things, don't worry too much about exactly what the graph looks like. We want the correct end behavior, we want the correct x and y intercepts, and that's about it. Again, does this thing dip down lower in between? Maybe, but we're not worried about that part. So that wraps up the notes for 3.2.